In some situations, our objective of data analysis is not really to predict future cases of the target, but simply rank ordering new cases, the new cases that are coming in the order of predicted values. Okay, the actual predicted values is not the main objective. One example would be, suppose if you have a bunch of new customers that are coming in and you want to rank order them in the order of how much money they will spend in the shopping experience. So you really are not interested in exactly how much money each individual customer will spend, but you want to simply rank order them, the top customer, the second top, and the third top, and so on. So if you have 1,000 new customers that you are approaching and you want to rank order them from the first most important customer to the 1,000th customer, and maybe you want to pay closer attention or give extra service to the top 10% or something like that. So in such an instance, the actual prediction y hat is not that interesting, but in the rank ordering that's of interest. So in such a case, lift chart is what is normally generated. The lift chart talks to that. So if individual prediction is what is important to you, then lift chart is not of much use. So it is not relevant if the goal is to predict the outcome of each new record. But if you want to identify a set of records that gives the highest cumulative predicted value, then lift chart is a good measure. So how do you generate lift chart? So you first, of course, find the y hat values and then order the data set in highest to lowest in descending order of y hat. So what is your predicted list rank order? Okay, the top predicted to the last predicted. So if that is the prediction, now you move over to the actual values, which is also sorted by the y hat order. Now you start calculating the cumulative value of y. Now if your rank ordering on the basis of y hat actually rank orders y also in the same way, you will see all the high value y's at the top along with y hat. So that would be your cumulative y value is one variable that you will plot. But if the y hat is not doing a particularly good job, so that means it's going to be the cumulative y will be pretty close to simply cumulative y bar value. So you plot the cumulative y bar value and the cumulative y value ordered by y hat. So x-axis will be cases going from 1 to n. Plot two lines. One cumulative y bar value, that's your baseline, and then cumulative y value. Okay, of course, remember, before you plot this cumulative y, you have to first sort your data in descending order of y hat. Okay, so then this is what a lift chart would look like. So here is your y bar, and here is the cumulative. So this is cumulative y bar. This is cumulative y with y ordered by the descending order of y hat. So the farther away, suppose if y hat, the sorted y hat also sorts y values, then you will see the cumulative y value rising very quickly and then flattening and joining up like that. So the farther away the lift chart is from the baseline, the better the model is in rank ordering the actual y value. So the farther away the lift curve is from the diagonal, the better the model is. So a lift chart for a continuous response is relevant, remember, only when we are searching for a set of records that gives us highest cumulative predicted values. It is not relevant when our interest is to predict a single value in the future. When we talk about lift chart, there is a second variety of lift chart that we can prepare. The first one that we saw was ordering the y values in descending order of y hat and then finding a cumulative value going from the first observation all the way to the last. But here in decile wise lift chart, we do about the same thing. Okay, we order the y hat, descending order, right? Then we divide the observations after sorting into 10 equal parts. Okay, SAS uses 20 actually. SAS divides them into 20 equal parts. But in the textbook they talk about decile wise. Decile wise means you divide them into 10 equal parts. Okay, and then in each decile you find the ratio of y. Okay, so like you find the sum of y, and remember our baseline is y bar. So sum of y and sum of y bar within each of the 10 deciles, or sum of, or average of y and on y bar. Okay, that would also give you the same thing. And then you find the ratio of average of y divided by y bar in each of those 10 deciles. And then you plot that. So order the predicted y values from highest to lowest and divide them into 10 equal parts. SAS does it 20 equal parts, remember that. So for each decile, find the ratio of sum of y and sum of y bar. Okay, and then you plot that ratio. So look something like this. So you have 10 equal parts. So the first part, this is the ratio of y to y bar. So if the model is really good, you will find really tall bars in the top deciles and then tapering off down in this fashion.